This is section 1.2.4. We're going to take a look at symmetry in graphs. So we're going to test the graph for symmetry. So going straight into it, you may have noticed that this graph right here on the right is symmetric about the y-axis, meaning that if I draw this imaginary line and I were to fold the graph over that imaginary line, it would be the same. That's what symmetry is. Now, there's a way for us to be able to test that symmetry analytically, meaning we do stuff to equations. And if we do these things to the equations, we can prove or show if that equation itself has symmetry. And so there's three types of symmetry that we've talked about. We had symmetric over the y, symmetric over the x, and symmetric over the origin. Now, what we've practiced so far was reflecting. If I reflect a point, if I over the x, over the y, over the origin. Now we're going to test to see if the graph itself has symmetry. It's basically the same thing, except now we're doing quote-unquote proofs. So it's symmetric about the y-axis if I substitute in a negative x into the equation, and then I simplify the equation, and it's the same. It's symmetric about the x-axis if I plug in a negative in for the y, simplify it, and it's the same. And then it's symmetric about the origin if I plug in a negative for both the x and the y, simplify it, and it's the same. So that's the key thing. It has to be the same as the original equation for it to show that symmetry. So let's look at some examples. So in the previous one, we've already found the x and y intercept, right? What we're doing here is we're just focusing on the symmetry part. You might have been wondering, like, wait a minute, it's asking us to do two things. This lesson was the second thing. So to show if it's symmetric about the y-axis, what we need to do is we need to replace x with negative x. So if you notice, this is where my x was. All I did was replace it with negative x. Now, I have to try and show that this equation given here is now going to be the same as the original equation. Now, there's no way for me to simplify that negative x minus 2 and make it look like an x minus 2. So therefore, it's not the same, and it's not symmetric about the y-axis. Let's try it over the x-axis. So I need to plug in a negative for the y. So you're going to replace the y with negative y. Now the easiest way to do it is if you just kind of imagine there's parentheses around the y, and I'm just plugging in a negative y in for those parentheses. Now if I simplify this, negative y squared, negative y times negative y, you get a positive y squared. So the question is this the same as the original equation? Are these the same? Yes, they are the same, so therefore it's symmetric about the x-axis. And now we can do the origin. I plug in a negative for the x and the y. So if I plug in a negative for the x, negative for the y, well, this simplifies down, but I still have that minus x minus 2 here. So because I have that minus x minus 2 there, it's not the same, so therefore it's not symmetric about the origin. So for this particular equation, it is only symmetric about the x-axis. Now, take that equation, plug it into Desmos. Just write this exact equation into Desmos, and you will see how if you fold it over the x-axis, they're going to be the same. Let's look at another one. To be able to find if it's symmetric about the y-axis, I need to plug in a negative for the x value. So if I do that, remember we can imagine that these are parentheses and I'm just plugging a negative into it. So if I do that, negative x squared, negative x times negative x is positive x. They are the same, so therefore it is symmetric about the y-axis. Now if you're wondering, these three dots, those three dots in that triangle shape means therefore. Let's check the x-axis. Remember, I have to replace my y with negative y. Now, I have to compare and see, is that the same as the original? In this case, it's not. So therefore, it's not symmetric about the x-axis. And now the origin, I got to plug in both a negative for the y and for the x, see if they're the same. In this instance, I still have this negative left over here for the y, so therefore it's not symmetric about the origin. Let's look at one more. So if I want to find symmetry around the y-axis, I need to plug in negative in for the x. So imagine the parenthesis there. But if I plug it in, negative x times negative x is the same as positive x squared. So therefore, is this the same as the original? The answer is yes. So therefore, it is symmetric about the y-axis. Let's test the origin. I plug in a negative for both the x and the y. Now I know you might be thinking, oh, negative negative is a positive here. Nope, order of operations. I have to square the negative y first. So negative x and negative x is positive x squared. Negative y and negative y is positive y squared. That negative just gets carried down. Is that the same as the original? Yes. And then over the x-axis, you plug in a negative for the y value. Negative y times negative y is positive y squared. So therefore, it is the same. So this graph here is symmetric over the x, the y, and the origin. So what did we learn today? We learned how to test for symmetry to see if our graph is symmetric over the y, the x-axis, or the origin. How do I test if the equation is symmetric over the x-axis? You replace the y with negative y, and then you want to see if it's the same as the original equation. That's the key thing. After you simplify it, you have to check to see if it's the same thing. If it's the same thing, then it has that symmetry. The origin, you have to replace both the x with negative x and the y value with negative y. This does conclude our lesson. If you have any other questions, please leave them in the comments.